Welcome to the Interface Types module. By the end of this module, you should be able to configure various interface types. Here are the details for some physical interface properties. Data Link Layer Protocol and Keep Alives. You can change the Data Link Layer Protocol for the particular media type. For example, Point-to-Point Protocol, or PPP, to Cisco High-Level Data Link Control, or Cisco HDLC. And you can turn Keep Alives on or off. Link Mode. On Ethernet interfaces, you can hard-code the duplex setting to either half duplex or full duplex. Link Speed. You can specify the link speed on certain interface types. Maximum Transmission Unit, or MTU. You can vary the size from 256 to 9,192 bytes. Clocking refers to the interface clock source, which can either be internal or external. Scrambling refers to payload scrambling, which can be on or off. Frame Check Sequence, or FCS. You can modify to 32-bit mode. Note that the default is 16-bit mode. Diagnostic Characteristics. You can enable local or remote loopbacks or set up a bit error rate test, or BERT. Here are the details for some logical interface properties. Protocol Family refers to the protocol family you want to use, such as Family INET, INET 6, ISO, MPLS, or Ethernet switching. Addresses refers to the address associated with the particular family, such as IP address using Family INET. VLAN tagging refers to the VLAN tag. Firewall filters refers to the stateless packet filtering configuration. A stateless firewall filter enables you to manipulate any packet of a particular protocol family, including fragmented packets, based on Layer 3 and Layer 4 header fields evaluation. You can apply a stateless firewall filter to an ingress interface, an egress interface, or both. Other characteristics. Some other configurable options include RPF check, policers, and accounting. All interfaces have the same configuration hierarchy organization. Junos OS considers all properties defined directly under the interface name to be the physical properties of that interface. The unit number represents a particular logical interface. Junos OS considers all properties defined directly under the unit number to be the logical properties of each specific subinterface. Here are two configuration examples. The first configuration example displays a Layer 2 Access Mode Ethernet interface. Access Mode interfaces are used when the port is being used as a Layer 2 port, and the connected device belongs to a single VLAN. In this example, GE0/0/0 is part of VLAN 10. The second configuration example shows a Layer 2 Trunk Mode Ethernet interface. Trunk mode interfaces are used when the port is being used as a Layer 2 port, and the port carries traffic belonging to multiple VLANs. In this example, the GE0/0/0 interface handles traffic for multiple VLANs, multiplexing the traffic for all configured VLANs over the same physical connection, and separating the traffic by tagging it with the appropriate VLAN ID. Also, the GE0/0/0 interface carries untagged traffic as it is configured with the native VLAN ID configuration option. Both configuration examples are configured for Layer 2, which uses the Ethernet switching protocol family, and the respective VLANs are configured at the Edit VLANs hierarchy. For more information on configuring Ethernet switching ports, refer to the Enterprise and Service Provider switching courses. Here are two configuration examples. The first configuration example displays a Layer 3 VLAN tagged gigabit Ethernet interface with two logical units and corresponding VLAN IDs. The logical unit 100 corresponds to VLAN ID 100 and is configured to be part of the 172.20.100.1/24 subnet. Similarly, the logical unit 200 corresponds to VLAN ID 200 and is configured to be part of the 172.20.200.1/24 subnet. The second configuration example shows a simple Layer 3 interface without any VLANs and is configured to be part of the 192.168.100.1/24 subnet. In this case, when there is only one logical unit, the unit number must be 0. Both configuration examples are for IPv4 routing, which uses the iNet protocol family. Link aggregation enables you to group Ethernet interfaces to form a single aggregated Ethernet interface, also known as a link aggregation group, or LAG, or bundle. You will now learn the steps used to configure a Layer 2 LAG. The first step creates a logical aggregated Ethernet interface. In this example, a single aggregated interface, called AE0, is created. By default, no aggregated interfaces exist. Even after configuring the AE0 interface under Edit Interfaces, it doesn't appear in the list of interfaces. To create an aggregated interface, simply add an aggregated device under the Edit Chassis hierarchy. Once this portion of the configuration is committed, the device creates the AE0 interface. With a device count value of 1, the system creates only one aggregate interface, AE0. If you attempt to create an additional aggregate interface, for example AE1, a commit error is shown. An illustration of this behavior is displayed in this example. The next step is to define the parameters associated with the AE0 interface. The AE0 interface configuration includes at least one logical unit along with the desired logical interface properties. The example shows the AE0 interface configured as an Ethernet switch Layer 2 with 3 VLANs. The example also includes the Link Aggregation Control Protocol, or LACP, under the Aggregated Other Options hierarchy level. As previously indicated, if LACP is used, at least one side must be configured in active mode to successfully establish the connection. The final step is to associate the member links with the LAG. In this example, 3 physical interfaces are associated with the Aggregated Ethernet Interface, AE0. Note that LAG support and configuration vary between the different Junos devices. For support information, always refer to the Juniper Networks Tech Library website. You can access this website from the reference links document. This is a basic Layer 3 LAG configuration. In this example, 2 gigabit Ethernet interfaces function as member links for the configured bundle, LAG. The sample configuration is from the Router 1 device. Note that the required number of aggregated devices needs to be configured under the Edit Chassis hierarchy with the device count command. The configuration for the Router 2 device is displayed. Welcome to the Configuration Groups module. By the end of this module, you should be able to use configuration groups to configure interfaces. Configuration groups enable you to create a group containing configuration statements and to direct the inheritance of that group's statements in the rest of the configuration. You can apply the same group to different sections of the configuration, and different sections of one group's configuration statements can be inherited in different places in the configuration. Configuration groups enable you to create smaller, more logically constructed configuration files, making it easier to configure and maintain Junos OS. For example, you can group statements that repeat in many places in the configuration, such as when configuring interfaces, and thereby limit updates to just the group. You can also use wildcards in a configuration group to enable configuration data to be inherited by any object that matches a wildcard expression. The configuration group mechanism is separate from the grouping mechanisms used elsewhere in the configuration, such as BGP groups. Configuration groups provide a generic mechanism that you can use throughout the configuration, but that only the Junos CLI recognizes. the individual software processes that perform the actions directed by the configuration receive the expanded form of the configuration. They have no knowledge of configuration groups. You can use configuration groups to separate the common interface media parameters from the interface-specific addressing information. The example places configuration data for Gigabit Ethernet interfaces into a group called All-GE, which is applied at the Edit Interfaces hierarchy. In this example, all configuration parameters defined within the All-GE configuration group apply to the GE 0/0/0 interface. If competing statements existed, the software would use the statements configured directly under the interface. Configuration groups can make determining the actual values used by a device running Junos OS difficult, because configuration data can be inherited from configuration groups. To view the actual values used by a device running Junos OS, use the Pipe Display Inheritance option after the Show command. This command displays the inherited statements at the level at which they are inherited and the group from which they have been inherited. As mentioned in the example, you can also add the No Comments option to exclude the inheritance notes. This command and output is the same as the code previously shown, but without the No Comments option. Note that it is possible to exclude comments using the Display Inheritance Pipe Except double hash option. In this case, you need to remove all the lines with double hash. With the Except double hash option, you might also not be able to view information about passwords and other important data where double hash is used. To view the complete configuration details with all the information without just the comments marked with double hash, use the No Comments option with the Display Inheritance command. Junos OS enables you to group a range of identical interfaces into an interface range. You first specify the group of identical interfaces in the interface range. Then you can apply a common configuration to the specified interface range, reducing the number of configuration statements required and saving time while producing a compact configuration. The example shows an interface range sample, which associates 6 physical interfaces with VLAN 10.